start out tonight. Let me start this record. And what do you have? Maybe you have stuff you can verbalize. If you can't, I'll give you an email address. Take a picture of it, send it to me.
Okay. The first thing I can verbalize. So.
Okay.
All right. It says find the midpoint of the line segment joining the parts R, and then the coordinates are 2, 4, and S, -3, 7.
You want the distance between those?
It says find the midpoint.
Find the midpoint. Okay. Hold on a second. Let me draw this a little differently. Let's put that one right there. It's S, which will make this one about here. That's R. Now, midpoint's actually pretty easy. Okay? The x-coordinate of the midpoint is your 2 x-coordinates added together divided by 2. The y-coordinate of the midpoint is your 2 y-coordinates added together divided by 2. It's always add together, divide by 2 to find the midpoint. Okay, so if I draw a line between those, what's the coordinates on that point right there? Add the x-coordinates, divide by 2. It's always the formula.
Okay. So -1 is the x, and then...
Hold on. Add the 2 coordinates. What do you get?
-1.
Divide by 2, what do you get?
-1/2.
That's the x-coordinate of the midpoint. Give me the y-coordinate of the midpoint.
11/2.
It's as simple as that. It always is that simple. So midpoint, it doesn't get it much easier than that.
Okay.
It's very, very simple. Okay. Now, let's just talk about for a second. What if they gave you, we'll call that Z, the midpoint. And they gave you R, but they didn't give you S. Because that's the other type problem you're going to get. Is where they give you one end point, and they give you the midpoint, and they want you to figure out the other end point. So how am I going to do this? In other words, they've given you R, they've given you Z, the midpoint. So how do you figure out what S is?
Don't you do the same thing with Z and then double it? Or?
A little different. The concept is a little different. Z is the midpoint. So first of all, how far is the x-coordinate of Z from the x-coordinate of R?
1/2? Or
does it look 1/2?
no.
What is it?
Like 2?
Alright, what you want to do is you want to subtract the x-coordinate of R to figure out how far apart they are. You want to subtract them. What you're subtracting is a -1/2. So how far apart is the x-coordinate of Z and the x-coordinate of R?
2 and 1/2.
There you go. How much further do you have to go to get to S?
2 and 1/2.
Okay. What's the x-coordinate of S?
5.
Minus 5.
Oh, minus 5.
Good answer. No, I'm sorry. It's minus 3. In other words, it's here. Let's look at a number line. Okay. Here's 2. There's minus 1/2. If I tell you that that is the midpoint from 2, then I got to go all the way over to there, right?
Mm-hmm.
What's that point?
-3.
Yeah. In other words, I got to go 2.5 to the left of minus 1/2.
Mm-hmm.
So it's -3. And do the same type logic on the y-coordinate. How far up do I have to go from 4 to get to 11.5?
Wait, repeat that?
How far up do I have to go? In other words, z is above the y-coordinate of r, correct?
Mm-hmm.
It's at 11.5, so that's 5.5. Of course it's above. How much further above is it?
11.5.
No, you're taking 11.5 minus 4. How much is that? In other words, 11.5 or 11 halves is higher than 4, right?
Yeah.
Okay, how much higher? Find a common denominator. Whenever you're subtracting fractions, you have to have a common denominator.
So it'd be 3 more?
3 halves.
3 halves.
In other words, 4 is 8 halves, right?
Mm-hmm.
Well, 11 halves minus 8 halves is 3 halves. So that's how far the midpoint is from the y-coordinate of r. How much further do I have to go?
3 halves.
Okay. So I got 11 halves is where I'm at. I'm adding 3 halves to that. What do I get?
You get 12 or 13 halves.
14 halves.
Yeah.
Just 7. So that's what that point is minus 3 comma 7. Now, I want you to understand this because this is really pretty easy. Okay? The midpoint is halfway between the 2 x-coordinates and it's halfway between the 2 y-coordinates.
Mm-hmm.
Very important concept. It's not some strange formula. You just do it by adding the 2 x-coordinates, dividing by 2, which gives you the halfway point. And to get the halfway point for the y-coordinate, you add the 2 y-coordinates and you divide by 2. It's always what you do. Now, when I told you to start with an endpoint and I gave you the midpoint, it requires a little extra thinking. You have to go. In other words, whatever this distance is, you have to go an equivalent distance to get to that. So it's an equivalent x distance and it's an equivalent y distance.
Mm-hmm.
All right. You probably have a problem like this. Go ahead.
Next one is, it's just another midpoint one, and the first one is -8, 3, and then the other one's -7, -4.
All right. Let's not even draw this. Let's just use the midpoint formula.
Uh-huh.
Takes the x-coordinates, add them together, divide by 2.
So So it would be
Add the x coordinates together, what do you get?
negative 15.
Divide by 2, what do you get?
15 over 2.
Minus 15 over 2.
Yeah.
Get your minus sign.
Mm-hmm.
Add the y coordinates together, divide by 2, what do you get?
You get negative 1 over 2.
That's your answer.
Okay.
That's simple. Okay? A little bit harder when you're going the other way. In other words, when they give you one endpoint and one midpoint. But same concept. Mechanics are a little different of doing it. What's your next problem?
Next one would be alright, so it says find the coordinates of the other endpoint of the segment. Given its midpoint and one endpoint.
Give me one endpoint.
Okay, so the one endpoint is 6, 2. And then the midpoint is 12, negative 1.
Okay. Now I'm not going to draw this, just because I want you to figure it out. Other endpoint. What is the other x endpoint? What do you have to do to get from R to the midpoint?
What?
What do you have to do to get from 6 to 12?
You have to double R?
No. It's always add and subtract. It's not multiplication we're doing here.
Oh, you gotta add 6.
Okay, so what do I have to do to get to the endpoint?
Add 6?
To what?
12? Or 6?
No, not 6, to 12.
Oh, yeah, 12.
In other words, if that's the endpoint, is this the midpoint? 12 is 12 halfway between 6 and 18.
Yeah.
Okay. Now let's do the same process. What do you got to do to get from R, y coordinate, 2, to midpoint, minus 1? How much do you have to go and which direction? It always comes down to that. Which direction?
So
What do you have to do to go from 2 to minus 1? Just picture it as a line chart. Okay? There's 2. There's minus 1. There's 0. What do I have to do to get from 2 to minus 1?
You have to minus 2.
Minus 3. This distance right there is 3.
Yeah.
And it's in a leftward direction. In other words, I'm going this way, right? I'm going from 2 to minus 1.
Yep.
So what's the other endpoint over here?
It would be negative 4.
You got it. That's the way you do it. Always.
Okay.
Now, if I were to draw this, let me just do it really quick. There's 6, 2. And the midpoint, hold on. I gotta always think ahead here. Otherwise my graph doesn't look right. So this is 6, 2. That's my R. The midpoint is 12 minus 1. Right? That's the midpoint. That's the beginning point. So the end point is somewhere down there. Well, notice I got to get from 6 to 12. That's going to the right by 6 units.
Yep.
So the next point has to be 18. I'm going to add 6 units going to the right. And the y coordinate, I got to get from 2 to minus 1, which is going down by 3. So I got to keep going down by 3 more. If I go down by 3 from -1, I get to -4.
Mm-hmm.
All right.
Alright, so now it's we're going on to finding the distance.
Okay.
So find the distance between the points -2, 5, and 1, 5.
1 what?
5.
What's the distance between those 2 points?
That would be 3, and then 3, 0, right?
The distance is just one number.
Oh, 3.
Exactly. In other words, that line I drew is horizontal and parallel to the x-axis, right?
Mm-hmm.
So it's just the difference in the x-coordinate.
Mm-hmm.
But it is 3. It's not -3. The answer is 3.
Mm-hmm.
Okay, so whenever they give you horizontal or vertical lines, they're very easy. You just have to work with one of the coordinates.
Uh-huh.
Okay, it's when they give you 2 lines that are not. Go ahead, next problem.
Alright, -2, -19, and then -3, -25.
Doesn't matter if these are not to scale. What you need is the distance formula.
Mm-hmm.
What's the distance formula?
So isn't it like square root of x1 plus x2,
Minus x2.
or x1 minus x2 squared, and then y1 minus y2 squared?
Okay. So all we got to do is plug in because we have them all.
Mm-hmm.
What's x1? And believe it or not, you can go from either one. You can go from the higher point to the lower point, or from the lower point to the higher point. Notice the square root's always going to give you a positive number. So it doesn't matter which one you do. How far is it from -2 to -3?
Just -1.
Okay, what's that squared?
1.
What's the difference between y1 and y2? And it doesn't matter whether you come up with positive or negative, you're going to square it anyway.
Uh-huh. So it'd be 8,
No,
which is 60. What?
it's 25 minus 19.
Oh, I thought that was a 17. 6,
Okay,
which is 36.
okay, what's my answer?
Root 37.
That's it, fully simplified. Now, in case you forget the distance formula, because a lot of people do, notice how you get that.
Wait, so on here it wants us to round to the nearest thousandth.
Oh, God, you got to be kidding me. Where do you go to school, Blake?
Mountain Vista.
Where? Mountain Vista?
Mm-hmm.
And you're a sophomore and they're still having you convert these to decimal?
Apparently.
Got a calculator?
Yeah, not a good one though.
Doesn't matter as long as it can do square roots.
Uh,
Gonna be 6 point something. Do it on your calculator.
no, this can't do square roots. God.
Yeah, it can. What kind of calculator do you have?
It's a one online. It's not like.
Even if it's online, you can do square roots. Your most basic calculators can do square roots. Just have to figure out how to do it. What calculator do you use in the class? Do you have a graphing calculator?
Yeah. Oh, so it's 6.08276.
You were supposed to round that off to how many decimals?
Nearest thousandth.
That's the nearest thousandth.
Okay.
In other words, this is the nearest tenth. That's the nearest hundredth. That's the nearest thousandth. So what's my final answer?
6.082.
83.
83.
That 2 gets rounded up because that's a 7.
Right.
If that number is 5 or higher, you round up. If it's less than 5, you round down.
Mm-hmm.
So this does teach you a little bit about rounding. But let's be clear, this is not a precise answer. That is an approximation. It's rounded off, right?
Uh-huh.
So we know it's not exact. Whereas root 37 is exact.
Uh-huh.
Root 37 is a much better answer. And it won't be long before they stop having you convert to decimal.
Mm-hmm.
Well,
no, so...
I mean,
Would it, I don't...
2. You will
Yeah,
no
they
longer
don't...
be converting to decimal. You'll be giving your answers in radical format because it's exact.
Yeah, what they do is they don't have us do that in, like, class or anything. It's just the, like, Math Excel is the homework thing they use. And
I get it. I've been dealing with this for 10 years. So
yeah.
I understand how sometimes you get to a certain level and they always have you convert it to decimal. It's kind of like turning pi into a decimal. But trust me, math is all about precision. So you don't have to go very high in math before they want the exact answer. And the exact answer is root 37. It's not 6.083.
Uh-huh.
Clearly, 6.083 is rounded off. It can't be exact. Whereas this, root 37, I can carry that out to 25,000 decimal places and it doesn't end. It's always irrational. It goes on forever. So if I want the most precise answer, it's root 37. Okay? Now, I'm going to show you how to memorize the distance formula.
Okay.
If the distance formula is the distance of a horizontal line, we've seen that it's super easy, right?
Mm-hmm.
If it's the distance of a vertical line, it's super easy. It's just the distance between 2 points. Mm-hmm. It's when there is some slope that it's hard. Notice that has some slope to it. Well, that's also the hypotenuse of a right triangle. Okay? Dimensions of this right triangle are 1 and 6, unless I got it wrong. What were the 2 points again?
Of which one?
On this problem, the 2 points?
-2, -19. And there was -3, -25.
Okay, I do have it. In other words, this distance is 6. This distance is 1. Right?
Uh-huh.
Now notice I don't put a sign on those. I don't say -1. I just say the distance between the x-coordinates is 1. Hold on. I'm sorry. I know this is confusing. This is actually 1. That's 6. You see why?
Mm-hmm.
In other words, the distance between the x-coordinates is 1. The distance between the y-coordinates is 6. The reason I don't care if whether there's a sign on it or not is because this distance right here, x, is the square root of the sum of the squares. In other words, it's 1 plus 36. That's the sum of the squares of the sides. In other words, it's the Pythagorean Theorem. That's all it is. If you understand the Pythagorean Theorem, and boy, if you don't, you need to. It's probably the most critical formula in all of geometry. Okay? In other words, when you have a right triangle, and one side is A and the other side is B, and the hypotenuse is C, then A squared plus B squared equals C squared. That's the Pythagorean Theorem. Notice that C is equal to the square root of A squared plus B squared. That's what that is. A squared is 1, so A is 1, so A squared is 1, and B is 6, so B squared is 36. So all you're doing is applying the Pythagorean Theorem. Even though when you look at this distance formula, it looks very complicated, it's just the Pythagorean Theorem. Your D is always C. In other words, the distance is always the slanted distance. And it's always the hypotenuse of a right triangle, whose sides you can figure out by the difference between the x-coordinates, the difference between the y-coordinates. You don't care about whether it's plus or minus because we're going to square it anyway. All right. What do you got next? We're just doing a half hour, Blake?
Yeah.
Okay.
That's all the problems I have right now.
Yeah, we probably have time for one more if you have another one.
I don't have any.
I can make one.
Yeah, you can make one.
Here's your 2 points.
Okay.
You want to find the distance between them. Is that a vertical or horizontal line?
Horizontal.
It's neither.
Yeah.
Vertical lines are vertical. They're parallel to the y-axis. Horizontal lines are parallel to the x-axis.
So
the distance is what?
It would be 25 plus 81.
Very good. What's that?
That would be root 106. And then...
Now, the question is, can that be... See, you're still at a point in geometry where they're going to have you convert that to a decimal, so it doesn't really matter simplification. But you're not far from where you have to simplify that and give it as a radical answer. Now, the question is, does any perfect square number divide into 106? And it doesn't.
No, yeah.
You know, I could say that's the square root of 2 times the square root of 53, both of which are prime numbers. So I'm not going to be able to factor this in any way that allows me to reduce that radical. So that is the precise answer. However, before we go further, just give you another one. Is that a precise answer? I mean, you could certainly put that into your calculator and get a decimal and then round it off. Like I said, they're not going to want that for very long. They're going to want you to be able to handle a radical and reduce it. So the secret is to factor 84, where one of your factors is a perfect square number. Well, over here on the left, I'm going to list my perfect square numbers. Does any of them divide into 84?
4.
Okay. How many times?
21.
So that's the first step. Now what's the square root of 4?
2.
Can I break down the square root of 21?
No.
I factor 21 where one of the factors is a perfect square number.
Yeah.
Okay, what
4
are
and 6.
9 and 3?
Or 9 and 3. Why did I say 4 and 6?
9 times...
Yeah.
No, excuse me.
No, yeah, no. Wait.
No, I got it wrong. 7 and 3.
7 and 3.
7 times 3.
Yeah.
Well, notice I can't reduce 21 anymore. So there's no point in splitting it into 2. The only time you reduce these radicals is if you can pull out a whole number. I cannot pull out a whole number from 21. So therefore, I leave it as that. That's my answer. That's what root 84 is equal to, is 2 root 21. Now, if you did the math, or if you put it into your calculator, you get 9.2 something. This is an approximation. This is exact. And this is exact, but it's not reduced. So you have to pay attention to a number of things here. You don't really want to turn it into a decimal unless they ask you to. And if they ask you to keep it in radical format, then you definitely don't turn it into a decimal, but you do reduce it. You reduce it by trying to find factors where one of the factors is a perfect square number, like 4. Okay? And now that square root of 4 turns into a 2. I still have root 21, which is root 7 times root 3, but that's not reducing it. In other words, turning a root 21 into a root 7 times root 3 is not helpful. It gives you 2 terms instead of 1. So you leave it as root 21 unless you can find a factor that is a perfect square number, and there isn't one. So this is not going to be long before that's your perfect answer to root 84. Now, if your teacher says, give me it rounded to the nearest thousandth, then it's going to be this kind of answer. And you might get that for another few weeks. But it won't be long before they want their answers left in radical format. Okay? Blake, I will let you go. And
all right, thank you.
Talk to you next time.
You too, bye.